Hello students, welcome back to OrganiChemVerse. In this video, let's discuss some of the previous year questions on cyclization reactions. In this reaction, you have to find out which of the following products will be formed when the given molecule undergoes series of reactions. What are the functional groups in the reactant molecule? There is an ester and amine. And you see there are acidic conditions in the reaction mixture. With this, you can tell that the ester will undergo hydrolysis during the course of the reaction to form a phenol because the bond will get cleaved here. So this is where you are going to get a phenol. Answer will not be 2 or 3. It has to be either 1 or 4. But you can see both of them are 5-membered cyclopentanone ring attached to the phenol molecule. Then how to predict what will be the product? Let's write down the series of reactions. The first reaction is with NaNO2 in acidic medium means what? It is a sodium nitrite taken in acidic condition. Nothing but we are preparing a nitrous acid. The nitrous acid is not stable like nitric acid. You should always prepare this in situ. In situ refers to while you carry out the reaction, you do it in the test tube and use it immediately, and you can't store it in the lab like HNO3. So when it is treated with HNO2, the NH2 will become a diazo salt, but since it is aliphatic amine, it will convert to an alcohol. Since it is converting to the alcohol, you see it will be a primary alcohol. The number of carbons here will remain same 1, 2, 3, and this could be either hydrolyzed here or in the next step, it doesn't matter. All right, so you can see that we are using an oxidizing agent CrO3 in acidic condition. So here it will get oxidized to carboxylic acid, and further we are using H2SO4 means what? So you can write down here itself that we are going to get a phenol here, and the formed carboxylic acid will form electrophile like this. So this will be the electrophile. So it could either attack this position or this position. How do we know that? Decide by the OH group. OH is a ortho-para directing group. With respect to this hydroxyl group, this is ortho. So it should go either here or here. But whenever we have a electrophile like this, it prefers to go to the para position due to the steric hindrance. Hence, what sort of product are we going to get? Fix the position of the hydroxyl group. So this is where we have CH2, CH2, and this is the ketone, and this is where the bond will be formed. So OH and ketone must be para to each other. Look for this one. The OH and the ketone are para to each other. Therefore, the correct answer is as shown in option 1. What about here? This might be the product, but it will be very less in quantity. It will be a minor quantity. So the question is supposed to be what is the major product. Hence, you can go ahead with option 1. In this question, we need to find out what is the major product after cyclization of this diketone ester molecule. So how to solve this question? First, identify the reaction condition. The sodium ethoxide under heating condition refers to a basic condition. That means what? First, we need to remove the acidic hydrogen. But where are the acidic hydrogen? First of all, there are no acids or alcohols to remove the acidic hydrogens, but there are alpha hydrogens. What are the alpha hydrogens we are talking? See, whenever we have ketone like this, the carbons attached to the functional group are called as the alpha carbons, and these alpha carbons are attached to the alpha hydrogen, and these can undergo enolization. So when this hydrogen is picked up by the base, like for example in this case there is a ethoxide, when it abstracts this proton, the formed carbanion can undergo enolization like this. So that means what? The corresponding hydrogen is acidic in nature. But these are not as acidic as the carboxylic acids, but since we are using a strong base, they can abstract such protons. What about the alpha hydrogen of the ester? Of course, these are also acidic in nature because when we remove this proton, so the carbanion can undergo resonance like this. It can form enolate like this. But what happens here is that the lone pair of electrons present on this oxygen can also exhibit resonance with this. So because of this side resonance, the hydrogen here might not undergo enolization, isn't it? This double bond is busy in enolizing the lone pair of electron on oxygen. That means what? It will not stabilize this particular carbanion. So what you can decide from this is that the alpha hydrogens attached to the ketone are more acidic as compared to the ester. So that means what? We have to remove from the ketone, not from the ester. So now you have decided that the ester alpha hydrogen is not used, but we are going to take either this or this. We can't use even these also because when you cyclize it over here, right? So you are not going to get a desired product as shown here. Here it's going to be 3-membered ring, which is also not stable. What about with respect to this hydrogen? 1, 2, 3, again not possible. But when we take this as a carbanion, look at this, when it attacks over here, like this, we are going to get a 5-membered ring. So 1, 2, 3, 4, 5. So this is where we are going to remove the alpha hydrogen, not even here. So based on the arrows, let's write down the product now. When the carbanion attacks here, this is going to become O minus, and we are going to get a 5-membered ring. That you write down first like this. Okay, this is the CH2, right? And this is the CO. This is the alpha carbon which attacked here, and alpha carbon is the one which is attached to CH2COOET, the ester, right? So eventually it will pick up the proton here, and you see there is a heating condition also. That means what? From the alpha position here, you will remove the hydrogen ion OH. That means what? There will be elimination of water, and we are going to get a alpha beta unsaturated ketone like this. And this will be the major product. And where do we have it? In option 4. Hence, the final answer is as shown in 4. In this question, you have to find out what is a major product when the given molecule is reduced with nickel and hydrogen followed by diisobutyl aluminum hydride. Both are reducing reagents, so the selectivity becomes very important for the given molecule because you see there is an ester and cyanide. Both will undergo reduction, but which reducing reagent will reduce which functional group? That you should know to solve this question. First, the nickel and hydrogen will reduce the carbon nitrogen triple bond and it will not reduce the ester. You should know that. So when the ester is as it is, like this COOET, the ester remains as it is. What about the nitrile? It will get reduced to CH2NH2. The triple bond is going to get reduced. So this will be the first reduction reaction. Then when we treat this with diisobutyl aluminum hydride, it is a very selective reducing reagent. It will reduce our ester to aldehyde. You can see that there is a bond formed between the carbon and hydrogen, and we are going to get an aldehyde like this. What about this group? CH2, CH2, NH2 will remain as it is. Now, both are reactive centers. That means what? The nitrogen is having lone pair and the carbon here is electrophilic in nature. Therefore, it's going to attack the aldehyde and aldehyde will undergo addition reaction. So once it undergo addition reaction, you see the oxygen will become negative, right? So this hydrogen will remain as it is. How many membered ring are we going to get? 1, 2, 3, 4, 5, 6. Therefore, you write accordingly. The nitrogen is the one which is forming here, right? So CH2, CH2 attached to nitrogen. And it is in turn attached to how many hydrogens here? 2. What should be the charge on nitrogen now? Plus. Overall molecule is neutral, just like here, okay? But oxygen is having negative charge, nitrogen is having positive charge. How do you balance it? The oxygen will pick up the proton from here so that the hydrogen will give away the electrons to nitrogen. And then what you are going to get? So observe carefully. This will become OH, okay? So now the nitrogen is over here. This will remain in its place like this. The neutral charge on nitrogen is because of the lone pair like this, okay? The 2CH2 group will remain as it is. Now, This molecule is not stable because when you have nitrogen with alpha carbon over here, if there is a hydroxyl group, it is not stable. So this will undergo elimination, condensation, removal of water. Therefore, what you are going to get? Imine. Imine refers to carbon nitrogen double bond like this. So this will be the final cyclized product and it is given as option 2. First, you can eliminate option 1 and 3 because they are not cyclic product. So apart from the benzene, there has to be one more ring over here, which is not possible. So what should be the product now? 2. In 4, the double bond is missing. So you can eliminate this. So students, if you know the selectivity of the reducing reagents, you will get the corresponding functional groups, aldehyde and amine, when they react, right? So they are going to form alpha hydroxyamine, which is not stable. It will undergo dehydration to form the corresponding imine as shown in option 2. What is the major product for the given reaction? So there is a phenol molecule and you can see there is a side chain with the double bond and the first reactant here is hydrochloric acid. So what should happen? There is an electron rich center which will take up the proton from the hydrochloric acid. That is the first step. Since the alkene is unsymmetrical here, you have to use the Markovnikov's addition. The hydrogen goes to the carbon with more number of hydrogens like this so that it will form a stable carbocation. So when the hydrogen goes here, this will become CH3 and then there is a plus charge. Attacked by the chloride ion, what we are going to get? We are going to get a product with the halogen. So you can count the number of carbons 1, 2, 3, 4. So 1, 2, 3, 4. Here we have a chlorine. And look at this. Next we are using anhydrous aluminum chloride. When do we use this? Either Friedel Craft acylation or alkylation. Since the compound here is having an alkyl side chain with the chlorine, it's Friedel Craft alkylation, right? The product is not a ketone. So that means what? This is Friedel Craft alkylation. Again, the carbocation will be formed over here, wherever the chlorine is there, and cyclization will take place. But the question is whether it will happen at ortho or para. The hydroxyl group present on the benzene, it's ortho-para directing, but there is a steric hindrance at the ortho position. Hence, it will undergo electrophilic substitution reaction at the para position. Therefore, what kind of product you can expect? You will get a cyclic product as it is an intramolecular Friedel Craft. And how many membered ring? 1, 2, 3, 4 and this one 5. So 5 membered ring. And wherever the carbon is attaching to the benzene, that's where the methyl is present. So a benzene attached to 5 membered ring, the OH must be para to the carbocation where it got attached, right? And there has to be a methyl. So check here. This cannot be the product because the OH group cannot be replaced by chlorine because phenols will not undergo nucleophilic substitution easily. The aromatic nucleophilic substitution on the benzene ring is not easy. Therefore, both 1 and 2 are not correct products. Okay. Now, let's check for 3 and 4. As I told you, the para should be the position of the ring form. So that means what? This is the correct answer, not the 3. So students, this is how you have to choose the correct answer by eliminating the at least 2 options and between these 2 molecules, compare the structure and choose the right answer. So this is the last question. You can take it as a homework question and try to solve this on your own. However, many students not able to solve the questions I generally include at the end of the video. So from now onwards, I'm going to give you a hint how to solve the question and you can continue solving the question. Say for example, in this case, you see there is a chlorine in carbon tetrachloride and then there is a double bond. Obviously, both the chlorines will get added to the double bond and methoxy group will remain as it is and that is what you can see in the option as well. So now how many carbons are there? You can write that first. Since there is a chlorine molecule, it will add to the double bond to form a vicinal dihalo compound. The next step is crucial because when you treat this with anhydrous aluminum chloride, the carbocation possible is possible either on this carbon or this carbon. So you know that in Friedel Craft alkylation, the reaction intermediate is carbocation. Which carbocation is stable? Generally, a tertiary carbocation stable than secondary than primary. So students, choose accordingly. So this carbon will form secondary and this will form a primary carbocation. Which one do you prefer to choose? That you have to decide and find the correct answer. In the next video, I will come up with some more interesting question. Please do like, share and subscribe my channel. Thank you.